So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss about the topic called as Introduction to Mineralogy. So before this topic, we have already discussed about importance of geology, importance of physical geology, and different kinds of importance as per the civil engineering point of view, how the geology is important, and weathering process, different weathering process we have discussed, that all weathering process, how it is important as a related to the dams, reservoirs, or any kind of construction works. So today we'll be discussing about the importance of mineralogy, because minerals are also a very important material which are used in the construction work. So as we see in day-to-day life, in construction works, in our day-to-day life, minerals play a very important role, as these minerals are present in the rocks. So these rocks, whichever rocks we are going to use in the construction works, how they are important to us, that we'll be learning today. So let us discuss about this importance of introduction to mineralogy. So in this we have different contents like definition to mineralogy, aspects of mineralogy, physical properties, mineral formation and occurrence, importance of mineralogy. So these all we are going to discuss today. So let us start with the definition of the mineralogy. So what is mineralogy? So mineralogy is a branch of geology that focuses on the study of minerals, including their composition, structure, properties, classification, and the formation process. So it plays a crucial role in the various scientific industrial fields such as geology, mining, material sciences, and the environmental studies. So because mineralogy is very important at the civil engineering point of view, as well as it is important in the, it's like how it is formed and how these all minerals are used in the different fields. Like if we talk about geology, if we talk about mining, if we talk about material science or environmental studies, so how these minerals are important to these all fields. So what are the aspects of mineralogy? So in aspects of mineralogy, we see the mineral composition, the crystal structure, and let us understand about the mineral composition. Like it determines the chemical elements that make up the mineral, like for example quartz or silicon dioxide or calcite or calcium carbonates. So these all minerals are important to us, and how these are formed, what are their composition, what type of other minerals are settled in that particular kind of rock. So what is their composition, that we have to understand when we study about the mineralogy. Now about the crystal structure, basically about the crystal structure, how the crystal in that particular minerals, how the crystals are arranged, in which manner it is arranged, that all we are going to understand. So studies the internal atomic arrangement of minerals using the crystallography. Examples like cubic, the different types of crystal structures will be as a cubic, hexagonal, or the crystal structure of mineral is a geometric arrangements of atoms, ions, and or molecules that make up the mineral. So the arrangement of these atoms determine the mineral properties. Now we have these internal arrangement of minerals. If you talk about this halite, it's NaCl, how the differently the arrangement of sodium and chlorine is given in this composition. Now if you talk about the structure, so there are different structures of the mineral. So suppose this is one example of the hexagonal structure. So if you see the structure of the minerals, it will be like a hexagonal, or it may be like a different pyrite. Like for example, you have a cubic structure. So in this you have the example, if you talk about the hexagonal structure, you have quartz. So quartz will be looking like this, or different cubic structures, we have different other minerals which looks in a cubic structure. Now if you talk about this mineral with a cubic crystal systems include like diamond, notable gem with a cubic crystal structure, garnet, a notable gem with a cubic crystal structure, fluorite has a cubic crystal structure and similar to the rock salt, pyrite can have a simple cube shaped crystals, galena can have simple cube shaped crystals, rock salts are common mineral with a cubic crystal structure, and cesium chloride has a simple cubic shell structures like this. Now if you talk about the physical properties of the mineral, if you study about the mineralogy, we should know about the physical properties of the mineral. So it includes the hardness, luster. So whenever a person is going to study about the physical properties of the minerals, they have to understand about the hardness, they have to understand about the luster, they have to understand about the color, the streak and the cleavage and the fracture and the density of these mineral. So for example, diamond is a hard set natural mineral. Like if you want to measure the hardness of the mineral, so we call it as Moho scale. In the Moho scale we have a hardness from 1 to 10. So if you measure in the Moho scale, the hardness of the diamond is 10. So the hardest mineral here is diamond. So mineral classification, if you talk about mineral classification, mineral are also classified into silicates, carbonates, sulfides, oxides, native elements, etc. based on their composition. So this is what I was talking about, the Moho scale. So in Moho scale you have different kinds of classifications based on some examples it is given. So here you can see talc. Talc is categorized as 1. So 1 is the softest mineral. This is the softest mineral here in the Moho scale. If you talk about, the softest mineral is talc and the hardest mineral is diamond here. So this is the hardest mineral. So as for the Moho scale, so this mineral is the hardest one and this talc mineral is the softest one. So as compared to the talc, we have the second one is gypsum. So gypsum is the second softer mineral, but the talc is the softest. Then after gypsum, then you have a calcite, then you have fluorite, then you have apatite. So these are the few examples how and the Moho scale the hardness are distributed and how the hardness are categorized or classified. Now if you talk about orthoclase is 1, quartz is 1, topaz is 1, corundum is 1, and diamond is one of the most hardest mineral type. Now if you Moho's hardness scale, again we have the same picture here, diamond, and here you can see the lowest is the talc. So it will be divided into or classified between 1 to 10. So lowest is the softest and the maximum is the hardest. Now this was about the hardness. Now you talk about the luster. So when you talk about the mineral property, we should know about the luster here. So luster is a kind of property here where the mineral is shine, or if you talk about the appearance, the glassy look of the mineral will be classified. So luster will be two types here, metallic and non-metallic luster. So if you see these two examples here, we have this low luster, here we have high luster. So if you talk about diamond, so diamond is like a glassy look or a shiny look it has. So we call it as a high metallic or high luster here. Now here if you talk about low means it will be having less shine. So that's why we call it as low luster. So luster refers to the way of mineral reflects light from its structure. It is important physical property used in the mineral identification. Luster is broadly classified into metallic and non-metallic type. So metallic means here it which looks like a metal. So the shine of the mineral will be like a metal. So here you can see these two examples which looks like a metal. So metallic luster is mineral that appear shiny like a metal. They reflect light strongly and are often opaque in color. And the examples of mineral here is pyrite. Pyrite is one of the best example of the bright metallic yellow which looks like a gold, and we call it as a fool's gold. This is the example of pyrite. So it has a golden metallic structure or golden metallic luster which shines like a metal, and metallic bright yellow. And galena is one of the metallic structure, metallic mineral which has a shiny lead gray. Now if you talk about magnetite, dark metallic black color. Now here non-metallic luster, non-metallic minerals do not look like metals, have a various luster types like vitreous. We have a pearly. So vitreous looks like a glassy kind of. So here the appearance will be not like a metal. Here you have the example of metallic and non-metallic. So example here is metal will be shiny and non-metallic. Still it has a luster but it won't shine like a metal, right? So it has a vitreous look, like a glassy look. It has a pearly look. So in a pearly look we have talc, muscovite, and mica. Next, coming to the streak. Streak is one more property of the mineral here. So what do you mean by a streak? So streak refers to the color of a mineral in a powdered form. So when you just rub the mineral, when you see a mineral, it may look a green in color, it may look black in color, but once you rub on the streak plate, the appearance of that the powder form will be different. So it may give, if the mineral is looking like green in color, the streak may be white in color. So the mineral which whenever it is in a powder form, so that we call it as a streak. So streak refers to the color of the mineral in the powdered form, which is observed by rubbing the mineral an unglazed porcelain streak plate, and it is more reliable property than surface color because of the streak remains constant even if the mineral color varies. Now here you have different kinds of mineral which has a different streak. Now if you see galena looks like black in color. So when you streak on the streak plate, it has a black streak here. Same thing if you have talk about this site, so it has a green in color. Now or is ozorite, it looks black but appearance is blue in color. Now you have a morphite, it has a green look but it has a white color of streak. So the mineral in the powder form, how it looks like, that we call it as a mineral streak. Mineral cleavage, so this is one more property of the mineral here. Cleavage is the mineral tendency to break. So when you break a mineral, how finely it is breaking, whether it is breaking in the layers, whether it is breaking into pieces, whether it is breaking into a small powder form, so that we call it as cleavage. Cleavage is a plane surface. If you break a mineral, if it is breaking into a plane surface, that we call it as a cleavage. And same thing if it is breaking into uneven kind of fracture look, that we call it as fracture. So cleavage is a mineral tendency to break along the specific flat surfaces called as cleavage planes. It's caused by weak chemical bonds between atoms in the crystal lattice. Mineral cleavage refers to the mineral ability to break along with the specific planes of the weakness in the crystal structure. These planes are determined by the atomic arrangement and bonding forces within the mineral. Now, cleavage is an important property in the mineral identification and has a practical applications in geology, engineering, and the material sciences. Aspects of cleavage. What are the aspects of cleavage here? So when you talk about aspects, definition, what is the definition? First of all, we should know. So the tendency of the mineral that breaks along the flat surface, a flat, smooth surface, due to its weaker atomic bonds in the specific direction, that we call it as cleavage. Now, cleavage planes here, minerals may have one or more directions. It may have one or more direction of cleavage depending on their crystal structure. Now, a quality of cleavage here is perfect cleavage breaks easily along with the smooth surfaces like mica. Good cleavages forms distinct but less perfect cleavage plane like a feldspar. Poor cleavage is difficult to see as apatite. So this is how the cleavage look like if it is breaking into a flat surface. So this is the flat surface. If it is breaking into the flat surface, so it has a one side flat, two side flat, three side flat. If you try to break it with a hammer, so it will break like this as a flat surfaces only. Now you see here you have a one flat surface, here you have an uneven surface. That means here you have a flat again. So it is breaking from two side cleavage. It has a two side cleavage. Now this one, there is no cleavage in this because it has an uneven surface. So this comes under the fracture, whereas this two comes under the cleavage. Now here were some more examples of cleavage here. Like here you have a clear cleavage here. Like directly if you try to break it up, it will remove into pieces. Layer wise it will remove like this. So here you can see one more flat surface. So cleavage is basically when you try to break the mineral, how finely it is breaking as a flat surface. Next thing is fracture here. So what is fracture? When you try to break the mineral, either two things will happen, either fracture or cleavage. So fracture is a mineral, in a mineral is a way to break forming uneven surface. It's like a key feature used to identify the mineral. So here you have a cleavage 1, cleavage 2. So here it is breaking as a plane surface. Now if you see here it is breaking as a fracture kind of the uneven surface. So this we call it as fracture. Now if you have more examples of fracture here, you can see it is breaking into like a uneven faces, like asbestos here. This is also breaking into uneven faces. So that we call it as a fracture. So these are the examples of the fracture here. Density, which is the intrinsic physical property of the mineral that relates to composition of the mineral and the pattern in which the mineral atoms are arranged. So intrinsic means that the property is the same for the mineral no matter what the size or shape of the mineral is different here. So mineral formation and occurrence. Minerals forms through igneous, metamorphic, and sedimentary process. So these are the different rocks where the minerals are formed with a different process. Example, granite contains quartz, feldspar, and mica. So all the minerals are found in the rocks. Either it is found in the igneous rocks, either it is found in the metamorphic rock, either it is found in the sedimentary rock. So economic and industrial uses and importance here is minerals are used in construction, limestone, gypsum, electronics, silicon, rare earths, jewelry, and all. So you talk about this formation and occurrence. So this is basically it is found in rocks, whichever like metamorphic, sedimentary, or igneous rock, and it has a great application here. It is used in the construction as well as a electronics material as well as in the jewelry materials. So why the mineralogy is important? It helps to identify the valuable mineral deposits from mining. So when you study about the mineralogy, it will help you to identify the valuable minerals deposits from the mining. It supports the engineering projects by analyzing rock and soil properties, and it aids in the environmental conservation by studying mineral interaction with the ecosystem, contributes to the development of new material and technology. So this is the references which you can go through to find out the more content about the mineralogy. So mineralogy is very important to study about the different types of minerals, study about the different types of rock which are used in the construction work and day-to-day life. So this you can just go through with this references to find out the more content about it. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.